Games, very briefly, we'll try a game and see what we can learn from it. So what's interesting is games moved from being this thing that was violent and bad for kids to a holy grail of teaching science. So now everybody's like, hey, if you could only have games, everything would be perfect. So it's important. How can we use games efficiently and appropriately? And I know that by this time you must have been confused about all these technologies. You're like, wait, which one of them did what now? So I wanted to compare this to simulations for a little bit, because everybody compares them to simulations, and there's some point to that. So one, open-ended, which means like you can keep doing it for a very, very long time. Is that true for simulations? You can sit a kid there, can they keep doing simulations forever? Yeah, I mean, it's not an experience that's designed for them. They have to know what they're doing, and you have to give them a task to do. They can manipulate to their heart's content until they're very tired. How about games? Are they completely open-ended? It depends. All of them are trying to model something, but games have environments. Sometimes you can freely roam in these environments, or freely do things, which can be a plus or a negative depending on what you're trying to do. Is there an object to win in simulations? No, actually simulations are not designed that you win. You might get things right and somebody might clap, or you might get a hooray, but it's not really winning. Whereas in games, the object is to win. They tell you, listen, you have to do this. And this is what you're trying to do. There's a mission, and that's pretty important. So there's a model that represents real world. We saw that it's important for simulations because you're trying to teach something, right? Is it important for games? Does it have to represent the world?
No, it doesn't.
No.
Okay, not at all. Completely off the charts. Not representative.
It is.
It can. Like what parts should it represent, and what parts not necessarily?
Well, if you're doing something like physics, you'd want it to you want whatever going on to obey the law of physics.
Law of physics, exactly. So what happens is you can throw things and they will obey the law of physics, but you don't have to throw apples. You can throw hobgoblins or whatever, gnomes or something. But it has to follow the rule of physics. That's perfect. Actually, that's a very good differentiating factor. Feedback. What this means is when you're doing something, the system tells you how you're doing. You sometimes have this in simulations, but in games it's much more important. If you guys play games, you're familiar with the number of stars you collect. Angry Birds, anyone? Yes. So you have achievements, you have stars you collect, so it tells you how you're doing, which turns out in education is also very, very important. One thing about games is it continuously does that. It all the time is telling you how you're doing, how you're not doing, what's your goal, how many stars, how many points you should get to. Changing levels of difficulty. Do you have that in simulations a lot?
You can.
You can, and sometimes it's a good idea to differentiate. But with the games, it's one of the things at the heart of the game. It says, oh, if you're already familiar with this, let me give you a harder question. How about that? Now are you interested? Okay, now try to get 3 questions. Again, does it sound familiar with Angry Birds? Changing levels of difficulty. Actually, this is very interesting. I will bring up Angry Birds again because it's interestingly one of the most addictive games in the history of games. And people are always asking the question, why? And one of the reasons is changing levels of difficulty. Once you decide, you're like, oh, okay, I got this. I'm the Angry Birds person. It gets harder. So it's like, okay, no, wait. And it turns out that's very, very important for the last thing, which is motivation. It turns out that people are more engaged if they realize they can't do something. One of the researchers actually suggests that they hook people up to the computers and they realize when they win, they have positive feelings about that. But when they lose, they still have positive feelings. Because when they lose, they're like, oh wait, I have to do better. So they're motivated to do that. So motivation is the holy grail of gaming. People are asking like, why are these kids so motivated by games? And one of the theories that explains it is the flow theory, which is very famous. What it says is you're in the zone when you're really having fun and you're really engaged. And what we're trying to do in education is have kids really, really engaged. And so what is it about games, people ask? Is it because they kill things and kids like killing things? I hope so. I hope that's not the case. What they found is this. So there's 2 things have to be happening. One is the skill level that they need should be high. What happens if a kid is playing a game where the skill level required is low? Yeah, they get bored. They're like, okay, I can do this. I don't really have to worry about that. Okay, and apathy is one of these things that happen. And the other thing is challenge level. Are they getting a difficult enough task? Okay, so when you're not getting a difficult task and they can already do this task, they have apathy. Like, I couldn't care less about this thing. But when the skill level is high and they're getting a easy task and they're really relaxed, they're not optimally engaged. But when they have a high challenge and a low skill, then they get anxiety. Like, oh, okay, I can't do this. All right. The best thing is when they have a high skill level, you're giving them things they can do, but at the lower of them. And then the challenge level is high. They feel like, oh, okay, this is hard. I have to keep doing this. So that is the heart of the motivation. When we're thinking about educational games, we have to think about, does this game provide this kind of environment for the kids? Okay. So there are a couple of things. Engagement, okay, that's great. But what else is good about games? One of them is authentic learning environments. Authentic might be a bit of a stretch, especially when you're in space, maybe. But what it's trying to say is that it's replicating environments you might not be able to do in class. Small environments, larger environments, provided that, for instance, laws of physics and things like that are followed. It's well suited for inquiry ability because games start you off with a goal and they say like, well, figure this out. And then the kids are left with this question, how do I figure this out? So they have to ask themselves all sorts of questions, trial and error, find the answers and find the methods themselves, instead of you telling them, oh, all you have to do is this. That brings up self-regulated learning. Kids actually follow this step without you telling them. That's also part of the motivation. They're like, oh, actually I want to do this. Because it's designed in a way that will make them want to go further and find the answers to these questions. One of the best games in the entire history of games is called Myst. Some of you might remember this. It starts with them telling you nothing. And then you have to figure out even like, what is the point of this game? And that itself is a motivational tool that students really need. We don't want them to be totally in the dark, but we want them to be asking questions. So one of the important things about technology implementation, which is very true about games, is this. You don't tell kids what to do. You let them discover things, and you let them come up with some things on their own. It's not like, oh, we talked about atoms, and we did everything we could do about that topic, now let's reinforce it with a game. That's not where it shines most. You say like, take this game, what is this? What do you see in this game? What comes up? What strikes you? So kids who play this game, this is all based on research, they have increased understanding of science concepts, if the games are designed for that, and they use correct science terms and in context, which is also something very hard to do. That's one of the goals that are difficult to reach. But if the game uses them in context and accurately, then students actually learn a little bit better too. So what I'd like to do right now is play a game. You might enjoy it if you're into that kind of thing. It's called Crayon Physics. It's very simply drawn, but don't let that fool you. It's a level-based game. So what I'd like us to do is go back to the website. Can lead website. You probably guess where we'll end up. So there's a section on games, feedback for games. And 8th grade illustration has a try it section. On here, there's the download and install the game. There are a couple of links. The top one will take you to the game if you click it. And it will take you to this page. And you can download the demo. It will take very little time because we have a very fast internet here. What I'd like you to do is download the game to your computer. In this case, I have a Mac, so it's showing the Mac one. The other one's there as well. And let's download it and open it.
Hey Jenner,
Yes.
my 5-year-old plays this
Yeah.
and loves it. And he's gotten to like level 15 or something.
Really?
Yeah. He literally, but when he goes to bed at night, he's like, hey Dad, I thought of a new one. He starts like laying things out with his hands. He's fascinated with this.
We'll talk more about this. There are some things in this game that make it suitable for a very diverse group of audience. I really like it too.
Yeah.
So adults can play it, little kids can play it. So there are a lot of concepts that are in there. So once the game is downloaded, we're going to go ahead and start it out. In the meantime, I'll show you what it's like. So I have it here, and when you start the game, it has this very crude cartoon style drawing, which is a great indication to show that games do not have to be this three-dimensional, very expensively built console games. They can be very simple and still very engaging and very beautiful too. So you get this, even in the demo version, you get actually a lot of the levels. So for your teaching needs, that's going to cover everything you need. But if you want to play the game more, you can buy it, but the free version will get you a long way. So when you click on a new game, as you're waiting to download, I'll just show this to you. All right. I'm not sure why this is happening.
The download isn't really long time.
It is? Oh, okay. Mine came very, very fast, so we might have to just do this, and I might have to demo this. If I can actually, let me try.
It's starting to sleep. It mine, a box pops up. It starts to dead.
All right, it's a bit off. It says it's not about finding just any solution, it's about finding the most awesome one. You will realize there are many solutions, and that's an important tool to give to your kids as well. It's not just about going through the levels, it's just finding the best one. And the game actually tells you if you got an elegant solution. It says, well, you got the bonus for having an elegant solution, if you do it very fast. So what it does is you draw objects and you drop them, and it uses gravity and laws of physics to make a lot of things happen here. My drawing is a bit off. Oh, but there it is. So you can draw it, and then it will fall down, and it will push it. And these few levels basically show you what's happening. So you got a star. So that's part of the feedback. Okay, now I have a star. I did this well. Okay. It's showing you how to do things in the beginning, so you actually can progress. And now for another one, it will tell you in more detail where you can just draw something in here. When you drop it, it will actually start to move. You can drop another one. It's going very, very slow. But so this is one of the things you can use, and the game gets more and more complicated. This looks very simple right now. You're like, okay, what is that? And I'm like, I can do this. But soon it will get very, very complicated. So there are different kinds of ways you will have to draw and let the thing move. And it will move into simple machines. It will have levers and pulleys, which actually follow the rules of physics. And you will actually have to start to use them. So you can have the kids go through these as part of your lessons, physics lessons, and you can actually ask them to contemplate and think about different ways of doing things. One of the good things about this is you can let them play for a while and come up with their own conclusions about things. Instead of telling them, this is what's supposed to happen, you can tell them, what is actually going to happen. If you go back to the website, I'm just going to close this for a moment. If you go back to the website, this is an issue related to me projecting it over here because of the connection. Actually, locally, you will not have this problem. Okay, that's very bad. But if you go back to the website, this doesn't happen in the game. It's because I'm projecting it over here. The website, for instance, has a couple of things kids can do as an example. One of them is this. There's a level editor you can go back to, and it shows them a picture. It says, okay, now we've got this fact that the bigger it is, the bigger mass. So we can ask them a few questions. And the website CanLead actually shows them a picture of a larger mass and a smaller mass, and it says when you drop them, which one's going to come down first. So you first ask the kids, what do you think is going to happen? So predict, okay, before we actually try this, because then we can go back and look at these principles in this environment that actually has correct physics. So you can go to the level editor. How is the download going for people? Okay, maybe because we're all doing it at the same time. So the level editor is very cool because as a teacher, you can design levels, or you can make this an activity for students to design levels and work with them. So you can draw things, fix things in there. So I'm having all these mouse issues and space issues related to this. But the level editor is a place, for instance, where you can play around with these things. In the CanLead website, again, you'll see images of different scenarios of pulleys and levers where the students can play with them. So you may, okay, there's this question. Why would you use this to talk about simple machines or physics or
Because it's
gravity?
really fun. I'm already a dying addicted to it. I'm like,
Wouldn't it be better if you just took 2 weights and dropped them in class and be done with it? Like, why do you have to go through this game?
Mentorship.
Sorry?
Mentorship and learning.
Exactly. So you think there would be self-efficacy? They would be like, okay, I want to do this.
To
Okay.
move it.
Any other value you think would be added from
Good
this?
heart.
Other than motivation, obviously kids want to.
well, I think you can try it out a lot faster. The trial error thing is,
Yes, we've been talking about inquiry-based things, which basically says, you know, let these kids ask questions, come up with ideas, and then test them. Okay? This is a great environment for that. You can have all sorts of questions. I had a couple on our Candide page, but you can have others. Say like, what will happen when this happens? When I draw these? And the best thing is you can create your custom environments with these levels, save them, load them to the kids' computers, and then go through with that with them. So you can really customize it to your exact learning need. Okay? So that's one of the good, cool things about that as well. So Crayon Physics is a way of creating this environment that is, first of all, good looking too. I mean, is that important?
yes.
Yeah, actually that is one of the important things if you want to engage kids. And you can see that the drawing appeals to different age groups. 5-year-olds can play this, 18-year-olds can play this too. They will have the same the excitement and fun.
Well, Janeer, I was just thinking how high school physics kids creating a game or an illustration for a little brother or sister or an elementary age kid, if they were told, here's your audience, you have to draw something that, you know, illustrates this for another age level, but that's a good illustration of do they understand it. I just really got engaged in just a minute. I love that little star coming right at you. That's awesome.
Yes. Sorry, I'm having all sorts of technical problems here, which should not be happening. I can't go back to my presentation. Okay. Because it won't let me. Close.
Who's got music going?
That's the game.
Sing once.
No one.
Okay, got it. All right. So if we go back to the presentation, so that was one of the games that we looked at, Crayon Physics. Another cool thing about this is it has a version where you can actually have it on your iPhone, or there's a version for the tablets, which is important because schools are beginning to have tablets. And you wonder, well, what is the affordance of having a game like this in a tablet? And there are different kinds of things you can do, different things that kids can engage with their hands, pinching, dragging, so some things could be actually look more natural to them. On the laptop it looks like this is a blown-up version, but kids can basically have a game in this way as well. And actually it turns out drawing things with a mouse is not as good as kids drawing it with their hands. So this is one of the games that you can really tell the affordances of a tablet actually with the learning environment, especially with the game, because especially when kids are drawing these things themselves. So that's a very good development. And in our Candide webpage, there's a resource called Best Free iPad Apps for Science. Check that out because it was interesting ideas for you to use in your classrooms. Not all of them are games, but some of them are. They're very, very interesting affordances of having something like an iPad, which is important to point out here. And so there are other considerations. Sorry, I'm talking the whole time. I was hoping we would play the game. I didn't expect that the loading would be such a long time. But I hope when you go home you try it because it's really, really exciting. So the practice is the game goals should align with educational goals. That goes without saying. It's very, very important. And unfortunately, it's not always the case. So there's a lot of work that the teacher has to do to make sure of that. The second thing is winning should be based on knowledge or skills, not random factors. Some games have winning factors that are not related to learning, which is also a problem. Like, oh, now you aligned this correctly, let's move on. So that's not really an educational game. That's a game within some educational content, but it's not the same thing. Other things to look at, the game should address content, not trivia. Unfortunately, in many areas you have that as well, and in science you have to be careful about content too. So the dynamics of the game should be easy to understand and interesting, but not abstract or distant learning. One of the examples, actually, of one of my friends' games, they had this simulation where they had to connect batteries to a dog. Don't ask me, it's just they really had this. So the idea was to make sure a circuit runs properly, so to not short-circuit it, because when you did that, whatever object you connected to would suddenly burst into flames. I know, it's a weird, really weird one. So the problem was, when the kids were doing this, they realized it's more fun to put things on fire, so they were trying to get things on fire. So completely missing the learning objective because that was more fun to do. So that's, in games, is an especially difficult thing, so you have to watch out for that. Students should not lose points for wrong answers. That's not the kind of game environment or learning environment you want to show. They should actually try to achieve the right answers, but not be penalized for the wrong ones. So they keep trying, because trial and error is part of this. And the game should not be zero-sum exercises. What I mean by this is some games, one person wins, only one person can win. In educational environments, you should not have games like that. Like if you're doing things right, everybody should win. Okay? So it should not be zero-sum environments, and that's very important as well. So, integration strategy, there's a problem, which you all probably know too. Go out and try to find games. It's very hard. Because we're trying to do something. We talked about TPAC, so you need the game, the technology, you need the pedagogy and the content. Turns out it's a hard work to do all these. Which means when you go out and look for the technology, you find the game. So the games are out there, but you have a harder time to putting it in your classroom. So the next thing you have to worry about is this game about science? Now, this is a smaller segment, but it's still a lot. Actually, you can find a lot of science games or games that include science. The problem is, they usually don't have this, the pedagogy. Does this look familiar to you? So, you can Google, I want educational games on science. Well, it's tough. It's very hard to find them because people will do a game, but they will less likely do an educational game that's sound, or educational game on a content that is sound. Some organizations are trying to do that. On the CanLead page, there's a list of links, which will actually take you to some good websites. I can't guarantee all the content is good, but at least people are trying. So what do you need to do? One of the strategies to use is find the game, which is a technology game. And then check if the content is correct, the science is actually accurate science. And this is the work that we have to do together. And CanLead actually provides you with the tools to talk with other people, to say like, I found this game and I'm thinking about pedagogical applications of it. What do you think? Or how do you think we can apply this? So it's a great brainstorming area for these kind of questions as well with games, because the technology is the game. And there's still some work to do to make it pedagogically and scientifically accurate. And there are some resources here which are replicated in the CanLead file, so you don't have to copy and all these things. But this will get you started with some content games. And how's the download going?
A lot of people got it.
Yeah.
All right, so if you like, we can play around with it a little bit. We can actually, what we should do right now is go home, and when you go home, you download it, you can play with it. We should do some reflection over this, because there's still a lot of questions, like how can games be better integrated, how can CanLead actually help you work with games, and this specific game, how satisfied are you with this game, what do you think is missing, what do you think would be better with this game, okay?